If in a question you are given Sn in order to find Tn, then this is a rule that you can use to help you work out the question. So Sn minus Sn minus 1 will always be equal to Tn. So we will have a look at the proof behind this. You don't need to learn off the proof, but I would suggest learning off this rule. And then we'll have a look at an example where this applies. Okay, so if S1 is equal to term 1, then S2 is equal to term 1 plus term 2, and S3 is equal to term 1 plus term 2 plus term 3, etc. So S4 would be equal to term 1 plus term 2 plus term 3 plus term 4, and so on. If we just focus in on S2 and S3, so I've gotten rid of S1 because it's not actually a part of the proof. I just used it to explain where S2 and S3 came from. So focusing in on S2 equaling term 1 plus term 2, and S3 equaling term 1 plus term 2 plus term 3. Subtracting S2 from S3 leaves us with term 3. So S3 minus S2, so S3 minus S2 will leave us with term 3. And we can see that because the term 1s will cancel, the term 2s will cancel, and we're just left with the single term 3, or T3. So S3 minus S2 is equal to term 3. So to turn this into a general rule, instead of S3, we can write Sn. And instead of S2, we can write Sn minus 1, because 3 minus 1 is 2. And then instead of term 3, we can write Tn. So this is a general rule that we can use with arithmetic series. So just going back to our S3 and S2 again. So if Sn is S3, then Sn minus 1 is S3 minus 1, which is S2. And again, that gives us S3. So this is the proof behind the rule at the top in the yellow box. You don't need to learn off the proof, but I would suggest that you learn off the rule in the yellow box. Okay, so I've put a big red box around what I suggest you learn off. Example 3. Given Sn equals n squared minus 4n, find an expression for Tn and hence determine if the sequence is arithmetic. So hence means using what you found at the start of the question. So just a reminder, we're going to use the rule from this proof to work out this question. So Sn is equal to n squared minus 4n. So that was given in the question. So we know that we need to work out Tn, and we've been given Sn. So the next thing we have to do is to work out Sn minus 1. So to get Sn minus 1, we literally just replace each of the n's with n minus 1 and use brackets, because if you don't use brackets, then the order of operations will not be applied. The rule of BOMDAS or BIDMAS, whatever way you learned it, will not be applied. So just be careful to use brackets. So we replace n with n minus 1 and a set of brackets. And then we bring down the squared, the minus, and the 4. And then we replace that n with n minus 1, again with brackets. So next we just multiply out our brackets and simplify. So n minus 1 squared becomes n minus 1 times n minus 1. So n by n is n squared, n by minus 1 is minus n, minus 1 by n is minus n, minus 1 by minus 1 is plus 1. Minus 4 by n is minus 4n, minus 4 by minus 1 is plus 4. Then we simplify. So we bring down the n squared, minus n, minus 4n is minus 6n, and 1 plus 4 makes 5. So Sn minus 1 can be simplified to n squared minus 6n plus 5. So Tn is going to be Sn minus Sn minus 1. So that's from our rule in the yellow box. So we replace Sn with n squared minus 4n. and we replace Sn minus 1 with n squared minus 6n plus 5. Again, I'd advise to use brackets because you're going to have to multiply in this minus, and if you don't use brackets, then the minus will not get applied to the minus 6n and the plus 5. So just bring down the n squared and the minus 4n. Minus by n squared is minus n squared. Minus by minus 6n is plus 6n. Minus by plus 5 is minus 5. And then we simplify. So the n squares will cancel. And minus 4n plus 6n is 2n. And we bring down the minus 5. So Tn, the nth term, is 2n minus 5. So the question said, given Sn equals n squared minus 4n, find an expression for Tn. So that's what we did. And hence, we're going to determine if the sequence is arithmetic. So Tn equals 2n minus 5. That's from the previous slide. If a sequence is arithmetic, then Tn minus 1 must be a constant. So must be a number. So there should be no algebraic terms involved. So Tn minus 1 represents the common difference. So Tn we worked out in the previous part to be 2n minus 5. And then Tn minus 1, we just swap that n for a set of brackets and put n minus 1 inside the brackets. And again, be very careful and make sure you use brackets. So I've brought down the 2n minus 5 with a set of brackets around it. You don't actually need brackets around that because you're not multiplying it in anything at the start. But I just like to do it on both sides so that I don't forget about the right-hand side. So then I bring down the minus, and then I've got brackets around everything that represents the Tn minus 1. So I bring down the 2n minus 5, bring down the minus and the bracket, and then 2 by n is 2n, 2 by minus 1 is minus 2, and I bring down the minus 5 and close my bracket. So next I'm going to multiply in the minus. So bring down the 2n minus 5, and minus times 2n is minus 2n. And then minus 2 minus 5 is minus 7. So minus by minus is a plus, so you get plus 7. And then the 2n's will cancel. 2n minus 2n will cancel. And minus 5 plus 7 is 2. And 2 is a constant, so there's no n's in our answer. So therefore, the sequence is arithmetic. So this is another way to prove that it's arithmetic. So we take the nth term that we worked out at the start of the question. So Tn equals 2n minus 5. And we're going to find T1, T2, T3, and T4. So we're going to swap the n for a set of brackets and put 1 in the brackets. And 2 times 1 is 2, minus 5 is minus 3. So term 1 is minus 3. And in the same way, term 2 is 2 times 2 minus 5, which is minus 1. Term 3 is 1, and term 4 is 3. So we have minus 3, minus 1, 1, and 3, dot, dot, dot. And to get from minus 3 to minus 1, we plus 2. To get from minus 1 to 1, we plus 2. And to get from 1 to 3, we plus 2. So again, we can see that the common difference is 2. We're adding 2 each time. So again, the sequence must be arithmetic.